correctly now. Let me know if that's not the case. Again, I'm really happy to be here to share some of the ways that the River Authority has been using green stormwater infrastructure to meet these challenges that are related to stormwater runoff and ecological systems in urban areas. There are many environmental challenges in urban areas because of how we have historically altered the land and developed the land. In the past, we focused really only on flooding and flood mitigation, and that is a really important area to focus on. It was and is still very critical. But we know now that we can do it in a way that also allows for ecological function and services, and water quality does not have to be negatively impacted as much as in the past. So some of the major challenges in urban areas include the high stormwater pollutant loads that occur with runoff, the flow volumes, and the peak flows. And then also the lack of wildlife habitat, lack of native species biodiversity, lack of healthy ecosystems, and lack of landscape resiliency in the urban environment. And a lot of that is simply because there isn't a lot of vegetation in urban environments. And sadly, in many cases where there is vegetation, it is often not native vegetation. So we lose the potential for many other beneficial outcomes that would be provided by native plants. I'll be highlighting some of the urban demonstration projects that the River Authority has been involved in and their effectiveness on meeting these challenges that I just listed for you. The first project I'm going to be talking about is our stormwater retrofit project, and it included retrofits at two of our office locations, the main office, which is shown here on the map with the blue marker south of downtown. That's our main office, and then our environmental center, which is shown here with the red marker, and it is north of downtown. This project was made possible by an EPA 319 Clean Water Act grant. It was completed in 2016 to 2017, and it resulted in the implementation of best management practices that are identified in the Upper San Antonio River Watershed Protection Plan. This project serves as a local demonstration of urban retrofit permanent on-site stormwater management practices, in addition to providing all of the water quality improvements I'm going to be highlighting. And you can see here in the photo, this is just one portion of our project area. You can see the stormwater cistern here clearly. What you can't see probably is that we have a bioretention feature over here against the building, and then all of this landscaping that's surrounding is composed of native plants. So work at the main office included the installation of 5 stormwater cisterns, 9 bioretention features, and 22 permeable parking spaces. We used permeable interlocking concrete pavers for this system. And this photo on the right is that same cistern you just saw, but from a different viewpoint. So there's the cistern, and in this photo, you can see that bioretention feature much better, and you can get another view of more of that native landscaping that surrounds the area. So the 3 practices that we chose for this retrofit are practices that we had been finding out from others in the community were the practices they were most interested in, especially for retrofitting different sites. And so they each provide different levels of treatment. For stormwater, the cistern will capture that stormwater runoff, usually from rooftops, but there are underground cisterns. In our case, the ones we installed were all above ground, but they slow down that runoff. So they temporarily hold it, they capture that volume. So they reduce the volume that would have otherwise been going somewhere else. And with stormwater cisterns, the important thing that has to be done is that that cistern needs to be ready for the next storm. And so you can't leave that water in the cistern. So somehow you need to get the water out. You can use it for landscape irrigation in many cases, or in some cases, like what we did at our site, is you let it slowly release and possibly have it go into another practice like a bioretention feature for further treatment. The permeable pavement system you see here is very similar to what was installed at our site. We used the permeable interlocking concrete pavers. That's the upper surface layer here. And beneath that system, beneath that surface, you have a series of layers that provide filtering of that stormwater as it moves through that system. So the water hits at the top and is able to go through. You've got a structural layer that will help to support vehicles because this is parking space. But then beneath that structural layer, you've got multiple layers that help to filter out pollutants within that stormwater. And anything that makes it down to the bottom where there's a perforated underdrain, that water has been filtered and cleaned to some degree, and then prior to it being discharged. And similarly, you can see a cross-section of a bioretention feature here, which is very much like what we installed. And the difference here is that we've got vegetation as a part of this system. And so by having vegetation incorporated as part of the system, you get additional biological methods of treating pollutants that you just don't get with the other systems. You have a series of layers of material, again, in this system that also help to filter the stormwater. And then in the bottom, anything that makes it to this under drain for being discharged has been filtered and cleaned to some degree. So at our main office, before we installed these best practices, all of the stormwater runoff went in two different pathways. So we had the rooftop runoff that would go into a gutter system and then was piped into the ground in pipes that was directly connected to the underground storm sewer system, which discharged into the San Antonio River right next to our building. The other major pathway was the parking lot runoff, and the parking lot runoff would go directly to an inlet that was connected to the underground storm sewer system, and again, directly into the San Antonio River outside of our office. So after the practices were installed, we were able to provide that temporary storage of some of that runoff, holding it back, slowing it back, holding that volume back. We were also able to provide treatment trains, which are combinations of these practices in series. As I mentioned earlier, one example is having a stormwater cistern that slowly released into a bioretention feature. So that's a treatment train. We were able to add those filtration practices of the permeable pavement and the bioretention practices. We were able to reduce the runoff rate and the volume. And then the overflow and outflow would either go to other practices or into the storm sewer. But anything that did make it into the storm sewer was cleaner than it would have been prior. So it either was treated and filtered by a practice, or if it was an overflow situation, it's been diluted. So we have what's called the first flush. That's the dirtiest runoff. And usually that comes first. Once a practice reaches overflow, there's been a lot more input into the system and all of those pollutants have been diluted. So it's much cleaner, although not as clean as if it was filtered. So we were able to provide a lot of benefit here. At our environmental center, as part of this project, we installed two stormwater cisterns. These are each about 10,000 gallons stormwater cisterns, and they capture runoff from approximately 20,000 square feet of our rooftop that you can see here. Prior to installation of the cisterns, our rooftop would drain very quickly, send the runoff into the street and into an inlet to an underground storm sewer system that runs approximately along this roadway here, and then discharges directly into the San Antonio River within the museum reach of the Riverwalk. So this is the Pearl development here, if you're familiar with that area, and this is Newell Street. And so after the cisterns, we were able to provide that temporary storage. We were able to reduce runoff volume and rate as a result of that. And in this case, we pump the water out of these cisterns into a landscape irrigation system that's primarily composed of drip irrigation and some bubblers that help to provide supplemental irrigation for our landscape at this building. And then any overflow goes into the street and follows that normal path. But again, at the point of overflow, we've already captured the first flush and additional water has come in. And so anything that overflows is diluted from that first flush. And so what we've found with this project is that we have estimated over 819,000 gallons of potable water is saved annually because of these practices. 780 maintenance hours have been saved per year. One of the big things we hear a lot from people in terms of being reluctant to uh, um, design or implement green stormwater infrastructure is that they think that these practices are going to increase maintenance. But in our experience, our landscapes require less maintenance than our pre-project conditions, which were mostly mowed turf grass, which are very high maintenance landscapes and are very common landscapes in our area for commercial and residential. The other thing that we found is that we treat over 118,000 cubic feet of volume is treated per year. 289 pounds of sediment is removed per year, and 2 billion colonies of bacteria is removed per year because of this project. So if you can imagine, this is just one site, or well, two building sites, but in a sea of many other sites that do not have these practices. And if we were able to implement many more of these on-site permanent stormwater practices throughout the watershed, what a tremendous benefit that would be for our water quality, for our river health, for our watershed health. The next project I'm going to highlight is our high flow media BMP parking lot retrofit project, and this was at our environmental center. And so just as I showed you how our rooftop, which is here, drained directly into the river, our parking lot did the same. It followed the same exact path. So all of the runoff from this parking lot would go into the same inlet and go in the underground storm sewer system, discharging directly into the San Antonio River within the museum reach. And this is what happens in that section of the museum reach after rain events. And so these photos were taken at the Lock and Dam, which is just downstream from that outfall that I showed you. And you can see on the left the conditions that are pretty normal outside of rain events. Really attractive. This is the river. This is an economic generator in downtown. Many people visit it, residents, visitors. And after rain events, it usually looks like the photo on the right, and it might stay that way for some time. Um, we've seen it look like this, kind of like chocolate milk. We've even had situations where the river looked like black ink. It was just solid jet black, and that lasted for many days. So this is from all of that runoff coming in so quickly into our river. And this is the heart of our city. So I think these photos really speak to the importance of looking at different ways to develop land, ways to retrofit properties so that we can reduce our negative impacts on the river. Can you imagine how different your experience would be if you were visiting this section of the river on the day the photo was taken on the left versus the day the photo was taken on the right? And so we wanted to reduce our contribution to that issue. And we were curious about high flow media practices. We were a lot more familiar with those other practices I showed you, but not so much with the high flow media practices. And we were interested in that in particular because it has a very small footprint. And so we decided to install this type of a practice here and conduct stormwater sampling to see how effective it could be. And so our parking lot is about 6,000 square feet. And the surface runoff is directed into one area right here in the corner. And before installation of this practice, the water would be sent quickly to the street and into that inlet and then straight to the San Antonio River. We installed the high flow media BMP here to intercept that runoff and to treat it prior to sending it into the existing storm sewer system. The BMP we installed is called the Focal Point Biofiltration System. And this image shows a cross section of our BMP. At the surface, we have vegetation, and there's a layer, 3-inch layer of mulch. Below that is a layer that's 18 inches thick of the high flow media. And this media infiltrates at a minimum of 100 inches per hour, which is very fast. Below that is a 8-inch layer of bridging stone, and then a 9.45-inch layer of the structural underdrain that carries the water out. And then that's on top of a 3-inch level base. And what you probably can't see here because these words are too small is that it is wrapped in a containment geotextile, and that is meant to prevent mixing of the adjacent soils with the high flow media and the bridging stone. We don't want it clogging the system. And this is what the BMP looks like at the surface, integrated into the landscape of the parking lot. It was installed in 2020, so 4 years ago, and the surface area is about 40 square feet. So that's really small compared to some of these other practices. It receives that runoff from about 6,000 square feet of asphalt parking lot. And here we see it from the side. The runoff comes in from the left to that one point that I showed you earlier. It's directed to an inflow structure. As part of our stormwater sampling, that was one of our collection points for the stormwater coming off of the parking lot. From there, it's directed into a level spreader. And then from the level spreader, it's directed into the high flow media BMP. Once it's in the high flow media BMP, if it goes through the BMP, it gets filtered through the media and goes to the outflow structure. And then that is connected to the existing storm sewer system. And so for our stormwater sampling, that outflow structure is where we had another collection point for samples coming out of the system once they'd been treated. The other way out of this is if there's so much water that there's an overflow situation, it goes to an overflow structure over here and then out the normal path. And once again, in this situation, we've already received the first flush and more water has come in. So if it does overflow, it's going to be diluted from what would have been the first flush. But it is going to be untreated by the practice. And then we also had a sample collection point here in the event that there was an overflow. So as I mentioned before, we were interested in sampling the stormwater to determine the effectiveness of the BMP. And we had these 3 collection points I just mentioned and showed you. So we had the inflow that captured the unfiltered runoff straight from the parking lot. And that was a requirement for us to analyze the sample. We had the outflow where it was media filtered, and that was also required for us to analyze the sample. And then we had the overflow, and that would have been that unfiltered excess runoff, and it was not required for us to analyze the sample. We only had one event out of 5 where we did have an overflow, and that was the heaviest rainfall event. And I'll show you some more details on those events in a moment. We used a secure auto sampler for sample collection, and the samples were collected over the entire hydrograph. So samples were collected as the flow was increasing during peak flow, and then also as the flow was decreasing. We sampled 5 events, and the amounts ranged from 0.23 inches to 1.76 inches. And so it was that 1.76-inch event that resulted in the overflow situation. These events occurred between May 2022 and May 2023. And what we found was a reduction in the flow volume that was equal to or greater than 50% for all events, with the highest flow volume reduction being 92%. We also found peak reduction. You can see here on one of the example hydrographs for the event on May 25th. And additionally, we found pollutant reductions that on average were 96% for TSS, 75% for total phosphorus, 80% for TKN, and 81% for E. coli. So very promising pollutant reduction from a practice that doesn't take up very much space. Okay, so those last 2 projects were really focusing on water quality and water volume, runoff volume. And now I want to show you how we've applied beneficial landscape practices at our office locations that support wildlife habitat, healthy ecosystems, landscape resiliency, and native species biodiversity. The key is using native landscaping for vegetated stormwater management practices and other landscape elements. And it really is that simple. There are a lot of native plants to choose from. As I mentioned earlier, far too often our landscapes do not include native plants. And we're just missing out on a lot of the benefits that the native plants provide when we choose non-native. You can see here that the native plants can provide very attractive landscapes. They are not only functional, but they can be attractive. I mentioned the vegetated management practices, but we also here in this photo, this is one of our cisterns at our Gunther office location, where we were actually required to put up some screens to screen the cisterns from the Riverwalk. And at first we thought, oh my gosh, what's the big deal? But then actually afterwards, when we got the screens up and we planted this native vine called crossvine, it's an evergreen vine. I realized, this is actually a pretty cool way to take a practice that would normally have no vegetation component and add one. It's vertical element. We've seen with this particular vine, it gets beautiful red flowers on it. It's a hummingbird attractor. It attracts other butterflies and things. And in this case, we've got a monarch that's just resting on it. But it also provides cover for birds. It's a nice evergreen mat, and so some shelter and cover. And so it's just an example of how we can start thinking more about how we can introduce native plants into landscapes, even for situations where we maybe wouldn't have even thought to have a vegetated element. So I'm going to share some observations that I've made within a small native landscape area at our environmental center. So this is zooming into that environmental center a little bit more. I'm going to highlight some of the beneficial outcomes of using native plants to provide wildlife habitat, healthy ecosystems, landscape resiliency, native species biodiversity, all those things I mentioned before. And this area was converted from a lifeless turf grass landscape into a diverse native landscape in 2014. Right here, I'm just talking about this little area at the front of our building. And I started paying a little more attention to this spot in about 2016. I started using iNaturalist, which is a global citizen science database for tracking, documenting um, animals, plants, and I started going out periodically just to see what types of animals were coming to the native plants that we had installed. And I started seeing some really interesting things, and it really actually ended up, I got hooked on iNaturalist because of it, because I started learning a lot of new species, especially the insects that were coming. And I started really seeing even greater value to the native plants that we put in this highly urban area, and just how important a small native landscape can be in an urban area. And so when we talk about wildlife habitat, it can be provided in a number of different ways. It can be providing a food source, so like the nectar um, that's being used here by the butterfly, pollen. It can be fruits, nuts. It can be leaves, the plant, other plant parts. That can be the food source. Food also includes the insects themselves that are attracted to these plants. Many birds are coming in and feeding on the insects. And then, of course, it just keeps going. And so we've got other birds that, larger birds that, feed on smaller birds. So it's the whole circle of life that can actually be happening here. Habitat also includes places for wildlife to seek refuge, to find safety and shelter and cover. And I've got two photos here from our landscape. This is a common yellowthroat, and this is a migratory bird that happened to find our little habitat oasis. And it was using the Texas sage for cover, periodically going in and then coming back out and finding insects in the more open area, but then going right back in to the shelter of that Texas sage. And we see many birds doing that, particularly with that Texas sage. And another photo here, this is an ovenbird. This is also a migratory bird. And this photo is a little bit fuzzy because it was taken from inside the building through the window. I had a coworker come and say, there's this really weird bird outside my window. I don't know what it's doing. And I came in and looked, and it appeared to just be resting in there. It's was definitely during the migration period. Who knows how far this bird may have traveled, maybe thousand or more miles, and found our Texas sage and was able to seek shelter in there and rest and hopefully continue its migration. So you just really never know what might be out there using the sites. Um, Another type of habitat that you can provide is a place or space or specific plants that help a animal to reproduce, or a place for that animal to rear its young, or where the offspring can survive and grow. And so in the right photo, we have a native milkweed plant, and you can see a teeny tiny little milkweed caterpillar there. You can see how small it is next to these fingers here. That's a first instar, and we regularly see monarch caterpillars in the spring here. These native milkweeds are also larval host plants for another butterfly closely related to the monarch called the queen. And we have also regularly seen queen butterfly caterpillars, but in the fall. So with native landscaping, we can also support and assist in the development of healthy ecosystems. We can promote landscape resiliency by matching native plants to the specific site conditions, and by promoting a diversity of native plant species in the landscape. This approach can also support monarch migration in our area by integrating multiple spring nectar plants, multiple fall nectar plants, and those larval host plants that, again, match the site conditions. So on the left, we have a Mexican plum that a monarch is using for fuel, for nectar. And then there's that native milkweed supporting the larva of the monarch, the caterpillar. And this is a way to help support that spring migration when the monarchs are moving up north from Mexico through our area. And then on the right, we see Greg's mist flower is the patch here, right here, and echinacea right here, both serving as fall nectar plants. I'm going to just show a little video real quick. So all of these are monarchs, and every now and then we get these groups of anywhere from 5 to 15 monarchs, and they will very often be on the Greg's mist flower. If it isn't blooming or it's already covered by queen butterflies or other butterflies, those monarchs have these other fall nectar plants to go to. And so that speaks to that need for a diversity of plant species and blooming plant species, especially in the fall, because sometimes plants aren't on our schedules. And so if you've got at least something blooming there, there's a good chance it's going to support those monarchs. And it's important here in the fall migration because these are the monarchs that are heading south through our area on their way to Mexico. So not only can you have biodiversity in the form of the various plants that you include in the landscape, but those plants will each support further biodiversity by providing for wildlife. And these photos show the biodiversity I've observed on a single native plant species that we installed in our landscape when we converted it from that turf grass situation. And this plant is called Texas frog fruit. At least in our area, this has a wider native distribution than just Texas. So in Florida, they call it something else. It's native there too. But we call it Texas frog fruit here. And these photos show over 40 different species that I've observed and been lucky enough to get a clear photo of using this in our landscape right outside the building here. This is the one plant that really got me hooked on iNaturalist and documenting the species because I started seeing all of this diversity really very quickly in the heat of the summer when there's hardly anything else going on and you can barely stay outside for a couple of minutes, this plant is very often covered in blooms and covered in a variety of different pollinators and other insects. And so what I've been able to document so far is 18 species of butterflies, moths, and skippers using it. And even though these might look like they're the same, these are all different species of butterfly. 12 different solitary bees and wasps, and 10 different species of flies. Some of them known as bee flies. They look just like bees. And this one looks just like a Mexican honey wasp. So sometimes if you're not looking really closely, you might think that you're seeing a bee or a wasp, but it's actually a pollinating fly. And then, of course, the European honeybee as well. Um, so these photos were taken over the years. Again, really started doing it in 2016, but in a very casual way. There are definitely more species using this frog fruit. I just haven't gotten good photos of them. I've gotten blurry photos of some other things. I still don't know what they are because the photos were blurry. But there's probably a lot more out there also using it that I just haven't seen, haven't been out there. I go out periodically, 5 minutes here, 10 minutes there, just to see what's going on and really trying to look for anything new. But this just really speaks to how one single plant can really provide a tremendous benefit uh, for wildlife in your landscape. And this is a plant that actually is tolerant of almost any site condition you can give it. It does best in sun with a little bit of moisture, but it can take extremely dry conditions. It can take full shade. The only thing that I know is a problem for it is deer pressure. So deer will eat this plant, but in that situation, you can mix it with other things and maybe have it work better. But it is almost bulletproof and is an excellent plant um, urban locations for sure. So some of the other data that I've collected, observations I've made and put into iNaturalist that I want to share with you are about the bird species that I've seen out in this little landscape area. And so 15 bird species doesn't sound that great because 15 doesn't sound like a really big number, but it's actually the composition of the species that is of interest here. So one of these species, the Virginia rail, is outside of its range. You can see in the range map, the blue indicates non-breeding range or where they spend their winter. So along the coast, but really we wouldn't expect this bird to be in our area normally. The orange represents breeding or summer range, and then the purple means year-round here. So that was a surprise to find that this bird was in the San Antonio area. 2 of the 15 species are breeding species. We've got the white-winged dove and the black-chinned hummingbird. And then 4 are year-round species, the northern mockingbird, blue jay, great-tailed grackle, and grasshopper sparrow. And if you look at their distribution ranges, you can see that some of them actually go into Canada, Mexico, Central America. And so we start seeing how some of these birds are of international significance because of their ranges. 5 of these species are migratory species. And so I already showed you that common yellowthroat that was darting in and out, feeding on insects, and then taking cover in our Texas sage. We had a sorrel rail, the ovenbird, that's the one that was sleeping in the Texas sage during migration, mourning warbler, and Wilson's warbler. And then if you look at their distributions, you can see all of these very clearly have very large ranges extending into Canada and beyond, Mexico, Central America, and even South America in some cases. And so these species are definitely of international significance. And they found our little oasis in downtown San Antonio. And then lastly, 3 of the species are non-breeding or wintering. We've got the Lincoln sparrow, the American goldfinch, and orange crown warbler. And again, if you look at their distribution, we've got species of international significance here that have found benefit in our landscape. And that's all the information I really had to share with you today. But to summarize, the Green Stormwater Infrastructure practices um, address many urban stormwater challenges, and they really can help to improve water quality in our river, in our watershed, by reducing pollutant loads, reducing flow volumes and peak flows. And they can address urban ecological challenges by integrating native plant communities. And in doing that, we can provide significant habitat, landscape resiliency if we're choosing those plants properly for the site. We can support biodiversity with the plants we choose and the wildlife that benefits from those plants. And we can help to promote healthy ecosystems within our urban areas. Thank you so much for having me today, and I would be happy to answer any questions.
Let me get back on the screen. Thanks, Lee, for a great presentation. I appreciate it. And I will second Lee's latter half of the presentation about iNaturalist. She and I were talking last week at our project meeting, and she mentioned iNaturalist to us, iNaturalist to myself, and I am just beginning to explore the many features iNaturalist has, but it's a great app to use to help you identify plants, insects, everything. So highly recommend getting on board and getting onto that. Thanks, Lee, for a great presentation. I appreciate it. Um, and I've been opening the chat feature. If you have any questions or comments right now, please use our chat feature right now. Or At this point, if you also just want to raise your hand by using that reaction feature at the bottom of Zoom, we can take questions there as well. But Lee, I just have some comments I've been getting on the chat so far. One individual, Caitlin, says that she loves frog fruit and she didn't realize how many insects are actually attracted to it because she always sees butterflies around it as well. Um, another
I
feature,
can speak to that just a little bit if you don't
yeah, go
mind.
ahead.
So I was the same way. I loved it. I knew it was a plant that could be used on so many different sites because I had seen it and had it in my own spaces in a lot of different conditions. Like I mentioned, the only space it didn't work is where I had deer that could access it and eat it away. But here in downtown, it really blew me away when I started noticing the diversity of species. And what I first saw was all of the European honeybees. So there are usually a lot of those on it. And I started just going to the patch and stopping and just getting my eyes used to the movement of the honeybees. And then once I got used to that visual movement, I could pick out anything that was different than that. And when I started doing that, and I have a zoom lens, so there would be, that's the best way to do is have some kind of a way to zoom in on these. And I could find that different movement pattern, and I would just focus on it and start taking photos. And like I said, a lot of times I was able to get good photos, clear enough for identification purposes. Sometimes the insects are just way too fast, or they just you can't get a good angle to get a good shot to try to figure it out. But um, I started seeing that diversity right away and started learning a lot of new species. I didn't know there was a bright green fly that looked like a bee. I didn't know that there was a fly that looked just like a Mexican honey wasp. When I took the photo, I thought it was a Mexican honey wasp. And then I uploaded it and I was able to see the eyes were actually fly eyes and not wasp eyes. And it had fly wing structure and not wasp wing structure. And then by uploading it into iNaturalist, I was able to get to uh, figuring out what it actually was. And so I've learned a tremendous amount from iNaturalist just by accidentally being in the right place at the right time and getting photos of things and being able to upload it and into the database.
Awesome. Great for that. Thank you. And also another comment was made that from Brendan saying some college courses are actually requiring students to use iNaturalist now, with someone also seconding saying that they had to use iNaturalist in one of their college courses from ACC. So iNaturalist is getting out there. I do have a question from you from C. Perkins. From a cost benefit analysis standpoint, how long does it take for the initial cost of the project to catch up to the benefits?
Oh gosh.
This would help justify the cost investment to a client if a similar concept were to be suggested.
Well, I'm not equipped to answer that in any detail, but it really depends on the practice that's being used. I'm sorry, I can't answer more specifically on that. It really depends on the practice or practices, and like anything you construct there are higher end materials and lower end materials. And so if you're, even with one practice, you could be using much higher end materials and driving that cost higher than lower end materials. So um, what I can say is that these practices can be beneficial, and there have been studies done. I just don't know any details. I haven't been involved in cost benefit analysis to say much more than that. Where these can be beneficial, they can even save money, particularly when you're incorporating these practices from the start of a project. And so it's always more expensive to go in later and retrofit or if you already have a full design to go in and redesign. But if you're thinking about these green stormwater infrastructure practices from the start, it can be comparable to the cost of a project or even less costly in some cases. But again, it just really depends on the project and the site and the practices that are being installed.
Yes. Thank you, Lee, for that. Just quickly, I saw a comment about can we get a copy of your slides? Are you available to provide us a copy of your slides for
Sure,
us to?
I can send you a PDF.
That'd be great. Thank you. And to also answer that, we have this presentation recorded that will be getting posted on the Greater Everett Aquifer Alliance website as well. Um, Another question I have for you, Lee, is more, I guess, towards residential and commercial homeowners or commercial business, commercial developments, excuse me. Um, do you have any, it's asked, can you tell us a little bit of how residential homeowners can implement GSI, especially with bioretentive features like rain gardens?
Right. So what I was showing you really were more commercial type applications,
Mm,
larger cisterns than you would typically have in a residential setting. Although some of the smaller cisterns at the Gunther facility I have seen in residential applications, but usually for residential sites, they're called rain barrels and they're much smaller. They're usually about 55 gallons versus the 5,000 gallon cistern. And you can put rain barrels in series. You can connect them to each other and actually get a lot of storage that way. And they can be utilized in the same way that the stormwater cistern can, as I mentioned. If you're doing it for stormwater management, you want to use that water. So either um, putting it into some other container so your rain barrel is ready for the next rain event, using it out on the landscape before you use any potable water, or setting it up so that it slowly releases into a vegetated area or maybe even a rain garden. And so the bioretention practice that I showed you, the commercial scale had all of those layers and engineered soil media and under drain. Usually in a residential setting, you're not going to have that level of engineering involved and usually not an under drain. But it, again, you might need one in certain cases, but in residential settings, we usually call those rain gardens. And they really can be very small. They can be really shallow and wide. You can mimic a rain garden practice by berming. If you have really shallow soils, you can create the similar type of function by berming. And what you're really trying to do is slow the water down from moving across the landscape. Um, Hold it temporarily if you can. So in a depression, or if you've bermed up an area, holding it temporarily behind the berm, and then ideally letting it infiltrate into the soils. And that will help to replenish the shallow groundwater that supports base flow in our streams. It helps to um, create healthier soils on your site. Um, and then permeable pavement is also possible. There are different ways to use materials to, instead of having an impervious patio, for example, using pavers that have spaces in between them and maybe vegetation, or maybe it's rock or whatever, but looking at ways that you can break up the impervious surfaces for sidewalks, for a driveway, for a patio, and instead using something that allows that water to go into the soil, or at least not be directed off site really quickly. Other things that are possible in some residential settings are simply, if you've got a gutter system, simply turning the gutter. Many places have the gutter directed on the driveway that is angled down towards the street, and then the street into the inlet and into maybe the nearest creek or river or whatever. if that's the case, it might be possible to just redirect that downspout. There's little flexible attachments that you can get to turn that water, instead of sending it right down the driveway, sending it into a landscape area, for example. And again, maybe installing a rain garden. And of course, you want to be really careful when you're starting to um, pond water up. And so there are some guidelines. So you want to look into basic guidelines if you're thinking about doing any of these practices. And generally, you want to keep any water at least 10 feet away from your home, from other structures. So you don't want to build a rain garden right up next to your house, for example. In our case, I probably should have mentioned at our Gunther building for our bioretention that I showed you that was right up next to the building. It was a fully lined system. So in that case, highly engineered with the soils media and underdrain, and it had an impermeable liner all the way around it. So probably should have said that when I was showing you those pictures, because it was right up against our building. So there are things you can do, but you want to make sure that you're not ponding water up right next to your building without protections in place. And the easiest way
Awesome.
to do that in a residential setting is by keeping it at least 10 feet away.
Understandable. Annalisa, I see you have your hand raised.
Yeah, I just wanted to let people know that if they want to learn more about how to incorporate these rain gardens and other types of LID and green infrastructure features into their own yards, we have an LID manual for the Edwards region on our website. You can download it for free, or you can go to the GIA store and buy a print copy. And we've been told that we have one of the most complete plant catalogs for native plants that are appropriate for our area in that manual. So check it out.
Awesome. Thank you, Annalisa.
Oh, and I put a link. I put a link to the guide on the chat.
Awesome. Thank you, Annalisa. I appreciate that. Lee, I have a question from Tina Hendon, kind of building off of our private sector, our residential conversation that we've been having. She's asking, have you had much response from the private sector and potentially using these GSI structures in residential or commercial developments?
So we have on commercial developments, and the River Authority did have for a time an incentive program. We no longer have that program, but we did incentivize a number of practices. We actually have on our website a dashboard that shows a lot of different projects around the San Antonio area that include bioretention, cisterns, and permeable pavement. And you can zoom in and out and go to certain practices and get the details on those as far as what type of practice it is and its water quality benefits. So those different parameters I mentioned on reduction in volume, reduction in E. coli, reduction in sediment, those numbers are calculated for all the projects that are on this interactive map on our website. So it's called our Green Stormwater Infrastructure map, and it includes photos too of the projects. So
Thank you
we
for
did
that.
have quite a bit of interest, and we had a lot of great projects built when we did have that incentive program. And that's where we realized what those three really common practices were that people were interested in: the cistern, the bioretention, another variation of bioretention is bioswale, and then also the permeable pavement.
Awesome. Thank you for that. And it looks like Michelle actually posted the link you're talking about to the
Thanks,
chat as well.
Michelle.
So
I
hopefully
was
that answers
hoping
your
she
question.
would.
You bet.
So I think that answers your question, Tina, but just let us know if it doesn't. I think I only have one more question and we could wrap things up, but I'm also not too sure if you can answer this because it's related to cost. And the question is just saying, how much did this wonderful structure cost without including the labor? I think she's talking it's Myra. I'm not too sure what structure you're talking about. My gut is telling me it's that high media filter
High flow
one.
media.
Yeah.
Unfortunately, that's the one I do not have dollars for. We have them somewhere here. The folks that were leading that effort are no longer with the River Authority, or I probably could have gotten those numbers ahead, but I don't have those offhand. I am looking into it. I do have costs for the Gunther Euclid retrofit project, and the two cisterns I showed you that were at our environmental center, which is the Euclid building, were $150,000. The practices that were put at our Gunther office totaled $330,000.
So Myra, sorry about that, but would you mind if Myra potentially connected with you with your email
No,
lead?
not at all.
Okay.
I don't have the answer right now, but I am curious. Others that I talked to are curious. It's was 4 years ago, so it just takes a little more digging.
Okay. Thanks for that. Okay, I have time for one more question, and I'm actually going to direct this to Annalisa. Um, Hannah has asked, where is this native plant list that you mentioned? Is that included in the manual?
It is included in the manual. It's in the back portion of the manual.
Okay, so Hannah, if you just click that link, it should be in the back of it. If it's not, please let us know. Let's see. Okay, Lee, if you're up for it, I have time for one more.
Sure.
Okay, cool. So it looks like Carmen has asked, what do you think is the best way to promote this kind of work with other businesses and homeowners?
Ooh, what is the best way to promote it? Well, it always comes down to cost. And so there's the cost element, and they have to see the value in it. But they also have to be able to see the benefit in it. And I think what we're doing here is just trying to educate through presentations like this, just showing, I think those photos of the river and what the river looks like shortly after rain events really speaks volumes as to how much more we need to do and should do for what is the heart of our city. Um, but people are going to they're going to need to care about it, and we're going to need to have the ability, the money to do retrofits. We need people to be thinking of incorporating green stormwater infrastructure from the start. And so our organization is really just trying to reach out to all audiences to try to get as much information out there to get as many people interested in it as we possibly can. Um, but I think we still have a ways to go. We've been at this for 10 years talking about it, and we had to look at ourselves and say, we need to walk the walk. We started talking about water quality and started talking about these practices and realized, oh my gosh, just like those projects I showed you, we are directly contributing to this problem. So we need to walk the walk. And that's what made us do the retrofit projects in the first place, and collecting the data to try to demonstrate that they are beneficial, and also showing that it can be done as a retrofit. Most people understand it can be done as a new construction. They're just reluctant because it's a newer idea here than in other parts of the country. These practices have been installed in other parts of the country for decades and are functioning very well. And in many parts of the country, they had to do it because of water quality issues. We're not in that situation right now. We're ahead of the game in trying to promote this and trying to get it in. We want to prevent that situation where we get our water so polluted that we then have to do something, right? We should try to protect what we have while we have it.
Awesome. I think it's a great way to end this. So thank you, Lee, for that. And thank you for a wonderful presentation. and a great Q&A session. So we're wrapping things up right now. It's 1 minute after 4:30. Like I mentioned earlier, this presentation has been recorded and we'll be getting this up on the GIA website probably first thing tomorrow morning. And to end things, I am going to turn things over to my colleague Rachel Haynes to give you a reminder for our next lecture series that will be happening in August. So Rachel.
Thank you, Nathan, and thank you very much, Lee. We really appreciate the talk. It was really interesting. I've already downloaded iNaturalist, so I'm very excited. Our next talk is our 8th WaterWonks lecture. It'll be in August, again, the 4th Wednesday of the month, which I believe is the 21st of August. We're going to have Dr. Tasnuva Udita. She's a regional climate analyst with the City of Austin's Office of Sustainability. She's going to be talking about the prioritization of riparian conservation opportunities in the Upper Guadalupe River Basin in South Central Texas. She's currently with the City of Austin's Office of Sustainability. She's also been with the Texas Water Company and graduate and doctoral instructional and research assistants at Texas State University, and a GIS analyst and research assistant at the Meadows Center for Water Environment. So a very well-educated and a really interesting talk coming up. So we're looking forward to hers again on August 21st. You can go to the same site you signed up for this one, so aquiferalliance.org. Events calendar, WaterWonks, and find the sign up for the 8th lecture, and it will be up tomorrow. So we'll look forward to seeing y'all there. Thank you again.
And just to clarify, the 4th Wednesday is August 28th. All good. So it's actually happening August 28th, but be on the lookout.
Thank you. Yeah.
No worries. So be on the lookout tomorrow for that registration link. So thank you everyone for joining us this afternoon. You're free to go to resume the rest of your day. And we just want to thank you for your participation.